Hello dear children, in a previous video we discussed measurements and experimentation exercise 1A. There actually we covered only conceptual questions. In this video we are going to discuss numericals and as well as what are the questions which we have multiple choice questions are there. So we are going to cover numericals and as well as multiple choice questions. My name is Naresh, welcome to our channel Physics Plaza. Numerical 1. Yeah, children, you can see the numerical even on the screen also. The wavelength of light of a particular color is 5800 angstroms. Then they are asking us to express it in nanometers and meters. So first we have to write what actually given. So it is given the wavelength. So wavelength of the color is given 5800 angstroms. So two questions are there. First one, they are asking us to express 5800 angstroms in nanometer. Children, in a previous class also which we discussed the relation between angstrom and nanometer. So we know that 1 nanometer is equal to actually 10 angstrom. Children, it's a very important relation. 1 nanometer is equal to 10 angstroms. But what we have to do? We have to express it in terms of nanometer. So angstrom must be written in terms of nanometer. So from this relation we can, as 1 nanometer is equal to 10 angstroms, 1 angstrom is equal to, we can write as a 1 by 10 nanometers. So now what we have to do, this angstrom value, just you substitute in this place. So here lambda is equal to, it is 5800 into, so in the place of angstrom we are going to put this term, that is 1 by 10 nanometer. So the 0 gets cancelled. So here lambda is equal to 580 nanometer. So this is what actually the answer is. Now in this B, they are asking us to express even in terms of meter. So this value we must express in terms of meters. So then if you want to write in terms of meter, we must know the relation between angstrom and meter. So children, we know that 1 angstrom is equal to 10 power minus 10 meters. So this value just we have to put in this place. So then lambda is equal to, it is 5800 into 10 power minus 10 meters it is. So this can be written as actually 58 into 10 power minus 8 meters. But according to order of magnitude, this number should be written in between, like so that it should be in between 1 and 10. So this can be written 5.8 into 10 power minus 7 meters. So this is what actually its value in meters. Just copy it. Now we will do the second numerical. So children, in the second numerical it is given that the size of a bacteria is 1 micron. Then find the number of bacteria in 1 meter length. So first just let us try to write what actually given. It is given the size of the bacteria is given. Size of the bacteria, let us say X. Size of the bacteria, it is given 1 micron. 1 micron is given. And they are asking us to calculate the number of bacteria. Let us say N be the number of bacteria. So they are asking us to find out the number of bacteria in a 1 meter length. So it is the total length. So the total length, let us say total length is X, is given it as a 1 meter. So this we have to find out. So how to find the number of bacteria in the length of 1 meter? Actually total length means what? If you can arrange all bacteria in order, let us say, you will get some X length, let us say. So how can you get that? Size of the bacteria into number of bacteria will give you actually the total length. So here total length X is equal to number of bacteria, try to understand. So size of the bacteria, it's let it be its value something like A. Let us say it is A. So total length is equal to number of bacteria into size of the each bacteria. What actually we have to calculate? Number of bacteria we have to calculate. So it is N is equal to X by A. So X is what actually total length. A is what? Size of the bacteria. So this can be 1 meter by. So 1 micron means what H is? 10 power minus 6 meters. So here you can substitute 10 power minus 6 meters. Meter gets cancelled. Then n is equal to 10 power minus 6. If you can take the numerator, it will become 10 power 6. So it is 10 power 6. That's it. So 10 power 6 bacteria can be fit in the length of 1 meters. Okay, student, copy it. In a numerical 3, it is given that the distance of a galaxy from the Earth is 5.6 into 10 power 25. Numerical 3. So the distance is given. Distance, let us say d is given how much? 5.6 into 10 to the power of 28 meters is given. Assuming the speed of light to be 3 into 10 power 8 meter per second. So speed is 3 into 10 power 8 meter per second. Now they are asking us to find the time taken by the light to travel this distance, which is a very simple formula. What is that? We all know that. So they are asking us to calculate the time. So we know that distance is equal to speed into time. Speed into time. Now they are asking us to calculate time. So here time can be written as distance by speed. So distance is given how much? Distance is 5.6 into 10 to the power of 25 by 3 into 10 power 8. So here if you can cancel this 10 power 8, you can take to the numerator. Then here 3 ones are, here 3 ones are, and here 2 will be. So here 1.8. So approximately what we'll get? 1.87. So this is 1.87 into 10 power 25 into, this will become 10 power minus 8. So it is 10 power minus 8. So it is 1.87 into 10 to the power of 17 seconds. So this is a time taken by the light to reach. So t is equal to 1.87 into 10 to the power of 17 seconds. Now next, numerical 4. Numerical 4. So it is given the wavelength of light is 589 nanometer. So wavelength is given 589 nanometer. So what is its wavelength in angstroms? So it's a lambda value only, but they are asking us to express in angstroms. Children, already we know the relation, that is 1 nanometer is equal to 10 angstroms. That's it. So this value you have to substitute in this place. Then lambda is equal to, it is 589 into 10 angstrom. So this can be, it is 5890 angstroms. That's it. Okay, copy it. Now moving to next numerical 5. So it is given that the mass of an oxygen atom is 16 U and find its mass in kg. So it's a numerical 5. Still mass is given, that is how much? 1600 U. So we have to express this mass in kg. So what is its value in kgs actually? Then first we should know what actually U is and how is it related to the kg. Then we can get the answer. Children, here U only we can call it as AMU, that is atomic mass unit. So here 1 atomic mass unit is equal to actually 1.66 into 10 to the power of minus 27 kg. So now in the place of U, we are going to substitute this value. So then mass is equal to, it can be 16 into 1.66 into 10 to the power of minus 27 kg. 26.56 into 10 to the power of minus 27 kg actually. But according to order of magnitude, this value should be in between 1 and 10. So we can write like this. 2.656 into 10 to the power of minus 26 kg. So this is how actually we can convert AMU into kg. So this relation we must know that 1 AMU is equal to 1.66 into 10 to the power of minus 27 kg. Now Next, numerical 6. Numerical 6. So it is given that it takes 8 minutes for a light to reach from the sun to the earth's surface. If the speed of light is taken to be 3 into 10 power 8 meter per second, find the distance from the sun to the earth. For suppose it is given that here is earth and here is sun. Let us say here is the sun. So here as light is coming, for this it will take 8 minutes, it seems. 8 minutes. Then we have to calculate this distance. So they are asking us to calculate the distance between sun and earth. So let us write what actually given. So time is given, it is 8 minutes. So children, whenever the time is given in minutes, let us convert into seconds. Why? Already speed also given in seconds only. So this can be 8 into 60. This will be 480 seconds. So time we got as a 480 seconds. And the speed is given already. How much it is? 3 into 10 power 8 meter per second. So we have to calculate the distance. So we know that distance is equal to velocity into time. So distance is equal to velocity into time. So let us substitute the values. 3 into 10 power 8 into, so it will be 480. So this can be 0, it is 4, it is 14 into 10 power 8. So as I told you that this number should be in between 1 and 10. So you should put what a point after 1 point. So here what will happen? Power is increased by 3. So this can be written as 1.44 into 10 to the power of 11 meters. So this is the distance. Of course, this you can express even in terms of kilometer also. So we know that 1 kilometer is equal to 10 power 3 meters. So this we can express like this. D is equal to 1.44 into 10 power 8 kilometers. 8 kilometers. Since 1 kilometer is equal to 10 power 3 meters. So you can express the distance in meters and as well as you can express in even kilometers also. As a children, did you remember the mean distance between sun and earth is only we can call it as a astronomical unit. Astronomical unit is a mean distance between earth and sun. Just copy it. Here is last numerical, that is 7th one. 7th numerical is the last one in this exercise. Children, it is almost similar question. It is given that the distance of a star from the earth is 8.33 light minutes. Light minutes is very important. Let us say here is earth. Somewhere else here is earth, let us say. So here is star, let us say. So the distance is given. The distance is given. How much it is given? 8.33 light minutes. 8.33 light. It is light minutes is given. First of all, let us see what is the meaning of this actually. So children, just let us recall. You may get confused. Sir, already we heard about light year. What is this light minute? So light year is a distance traveled with the light through vacuum in 1 year. But whereas this is a distance traveled with the light through a vacuum from star to earth is 8.33 in 1 minute. In 1 minute, how much distance it can cover? Light year is a distance covered in 1 year. Light minute means what? Distance covered with the light in a 1 minute. So that is actually meaning. So now they are asking us to express this value in terms of meters we have to express. So children, so did you remember what is the light year value actually? So we know that 1 light year is equal to 9.46 into 10 to the power of 15 meters. Approximately it is 10 to the power of 15 meters. Of course, even you can express in terms of kilometers also, that is 9.46 into 10 to the power of 12 kilometers. Now, children, we know that in 1 second, light can travel 3 into 10 to the power of 8 meters. Whereas in 1 minute, what is the distance traveled by light? It is 3 into 10 power 8 into 60 meters. So this can be written as 18 into 10 to the power of 9, or we can write it is a 1.8 into 10 to the power of 10 meters. Children, this is the distance traveled by the light in 1 minute, but they are saying it is a 8.33 minutes. 8.33 minutes. So in 8.33 light minutes. So this is a light minute actual value. So now let us see here. 8.33 into 1.8 into 10 to the power of 10. You will get it as a 14.994 into 10 power 10 it is. So this approximately we can round it to 15. So it is 15 into 10 power 10. But according to order of magnitude, this should be written such a that the number should be lying between 1 and 10. So it is 1.5 into, or else let me write here its value. This value can be written here. It is 1.5 into 10 to the power of 11 meters. So the distance 8.33 light minutes is equal to 1.5 into 10 to the power of 11 meters. Copy it. Here only multiple choice questions are left. Here we have just 5 multiple choice questions which we have. Even you can see the questions even on board also. Children, the first one, here 4 options are given. The fundamental unit is 4 options: Newton, Pascal, Hertz, second. So no doubt about it, second is a fundamental quantity, fundamental unit actually. But teacher, let us think about other units also. What actual options are given? So first option is the Newton. Newton is a SI unit of force. So let us write that also. So in first one actually, the children, so A is given Newton. So Newton is a unit of force. It's a derived unit. And B is given Pascal. So Pascal is a SI unit of pressure. It is also derived unit only, pressure. C, Hertz. So Hertz is a unit of frequency, derived unit only. And D is second. D is a second. It is a unit of time, which is a fundamental quantity. So the units of fundamental quantities we can call it as a fundamental units. Why? Because they do not depend on any other units and they are not derived. So option D is right. Option D is right. And here is second one. Which of the following unit is not a fundamental unit? Not a fundamental unit, children. So option A is quantity. So children, here length, time, mass, these are 3 fundamental quantities. So obviously these 3 are fundamental units only. So in this they are asking us to find out which of the following is not a fundamental unit, not a fundamental unit. So later option B is right. Okay, fine. Third question. The unit of time is, children, it is given. First one is light year. So children, option A, light year. So we know that light year, 1 light year is equal to 9.46 into 10 to the power of 15 meters. So as it is a meters, obviously unit of distance. Now option B is parsec. Yeah, option B is parsec. So children, here 1 parsec is equal to 3.26 light years. So as light year is a meter, so what a unit of distance, so obviously parsec also unit to measure the distance only. C, leap year. It is leap year. So children, leap year is a unit of time. It is unit of time. And option D is angstrom. So here angstrom, 1 angstrom is equal to 10 to the power of minus 8 centimeters or 10 to the power of minus 10 meters, or even we can express 1 by 10 nanometers also. 1 by 10 nanometers. If you can see the children here, A, B, D. These all are the units of distance. But what they are asking? They are asking us to find out the unit of time. So obviously leap year. So option C is a right. So here the fourth bit. Here is the fourth bit. 1 angstrom is equal to. So here actually 4 options are there. First option is in nanometer, second one is a centimeters, third one is a 10 power minus 8, D is a 10 power 4 micro. So first let us write the options. Children, thinking about each and every options are very important. We have to think. Of course, finding the correct answer is important, but why other three options are wrong, that is also very important. So here first option is micron, 10 power 4 micron. So children, first let us think about the relation between angstrom with these all these units. So we know that 1 angstrom is equal to 10 power minus 8 meters, sorry 10 power 8 minus 8 centimeters it is. And we also have this relation 1 angstrom is equal to 10 power minus 10 meters. And we also have 1 angstrom is equal to 0.1 nanometer, 0.1 nanometer, and 1 angstrom is equal to 10 minus 4 microns it is. So these are actually all correct relations. Now let us cross check here. So what they are saying, so 1 angstrom is equal to, so 1 angstrom should be, first of all let us check here, micron is 10 power minus 4 should be, it's 10 power 4, so it is the wrong option. And next let us see here 1 meters. So 1 angstrom is equal to 10 power minus 10 meters should be, but here not 10 power, so it is also wrong option. And 1 angstrom is equal to 10 power minus 8 centimeters. So it is 10 power minus 10 centimeters given, so it is the wrong option. Then what is the correct option, dear children? 1 angstrom is equal to 0.1 nanometer is the correct one. Okay, fine. Now fifth one. Light year is a unit of, light year is a unit of. So we know that, again I am saying to children, by seeing year don't get confused that it is a, here is a unit of time. Of course year is unit of time only, but they mentioned is a light year. First you should know what actually light year is. The distance traveled with the light through a vacuum in 1 year is equal to, is actually called as light year, which is equal to 9.46 into 10 to the power of 11 meters, sorry 9.46 into 10 to the power of 15 meters, even you can express in kilometers also, 9.46 into 10 to the power of 12 kilometers. So their option B is right. So light year is a unit of length. So dear children, so this is what actually unit A of measurements and experimentations, and there we discuss exercise 1A. There we covered all conceptual questions, numericals, even we covered multiple choice questions also. In the next class, dear children, we are going to discuss about least count. It's very important, and there even we are going to discuss about vernier calipers and screw gauge. So how actually, what is a vernier calipers, what is a screw gauge, and what is the difference between vernier calipers and screw gauge, how screw gauge is better over a vernier calipers. Literally even the practical oriented also, this vernier calipers and screw gauge are very important. These topics will be discussed in detail in next classes. Thank you so much, all the very